Right, question 16 on the higher paper. I'm obviously looking at the diagram there. You can see this is on circle theorems. There is a lot of videos on circle theorems on Core Maths. It's all of the 65. It's like 65A, B, C, D, E, F, I think, something like that. And then also the fact that we've got here letters involved with angles as well. If you are struggling with that part of it, go and have a look at video 114, which is setting up and solving equations to deal with perimeter and angles. Right, you're told that A, B, C and D are points on a circle. You can see that anyway. The line PQ is a tangent to the circle at B. You can see that anyway. PBA is 51. PBA is 51. ACD is W. There. ACD. And BAD is 2W. BAD is 2W. So all of that there, because I know students sometimes kind of confuse this and panic, because that looks horrible somewhere else. But all it's saying, it's just giving you the information that's on the diagram there. What we want to do is figure out what W is worth. You must show all your working. Right, it's not a nice question, this, in the slightest. What you have to spot is that, looking at, like, you've got your 51 there, that's the number that you've got to deal with. You should spot by the position of that number that this is an alternate segment question. Now, what that means is, when we get alternate segment stuff, if we have a circle, if I have a tangent, if I have a line that goes from the point where the tangent meets the circle, if I measure that angle there, if I draw a triangle using that line to any point on this side of the line, it will be the same as that angle there. So that's why it's called alternate segments, because that angle there kind of overlaps this minor segment of the circle there. And then if I draw, say I draw a line, a triangle, sorry, like that, that angle will be the same as that angle, because it's in the alternate segment. Okay, so look out for that. Look out for the tangent with an angle that kind of overlaps part of the circle in there. So what that means is, there's your tangent, there's your angle, there's your chord. So any line, any triangle, sorry, drawn in the big part of the circle, using this as its base or one of its sides, will have 51 at the top of it, which means that if I draw those two lines to C, it means that that must be 51. Okay, that is difficult to spot, I think. The next part is A, B, C, D are all points on the circle, which means that A, B, C, D is a cyclic quadrilateral, which means that the opposite angles in a cyclic quad add up to 180. And that angle is opposite that angle. Okay, just draw that on again. This is what makes this one tricky. You're kind of overlapping yourself when you look at your diagram here. Okay, well, that angle there is 2W, that's fine. This angle is W add 51. And we know from our circle theorem the opposite angles add up to 180. So that gives me an equation that I can solve now. Simplify this, so we get 3W plus 51 equals 180. Solve that quite easily by minusing 51. So I get that 3W equals, what's that going to be, 129. Divide both sides by 3, so we get W is equal to 43. Okay. The maths involved in that, once you've got it, isn't difficult, but it is a really tricky thing to spot, I think, that question. Right, let's have a little look at the mark scheme. So you get 1 mark for spotting that that's 51. That's what that says. B1 may be seen in a diagram, so that's there. Second mark for getting that, for then applying the opposite angles add up to 180. And then the third mark is for just getting that right, for getting it all right and getting to 41. You still get the second mark here, by the way, if correct implies first B1. Follow through there, 51. So you might have thought, well, if that's 51, that there might be, say 129, taking it off 180 or something like that. If you then do this angle, add W, add whatever you put there equals 180, you would still get a method mark, a kind of follow through independent mark there for that one.